Good morning and thank you and welcome. It's a snowy Thursday where I am. I'm in Stratton, Vermont with my family. Kids have off school, so they're doing some skiing and it's very pretty up here after you get to your walks and your cars shoveled out. So happy to be here this morning, with Ping Golf, and we're going to get to that here in a minute. But we have a few housekeeping things coming up. We have a number of seminars coming up in the next 2 weeks. On March 2nd, we have the challenges of a first-year head professional, which I think will be very interesting to see what happens when you go from being an assistant to a head professional. And we have 3 gentlemen who are in that class this year, and so that'll be interesting to hear how they overcome their first year jitters, so to speak. And then we have creating a culture to motivate with Sam Wiley on March 7th, and it's about your motivation and creating staff motivation, and and how to go about adding those things to your staff to motivate them during our long seasons. And then on March 10th, Michael Breed has invited us into his house, which is also his academy. So we're going to have an interesting time there. Michael has a first-rate academy where he does all of his instruction, all of his social media, tapes his radio show, or actually his radio show comes live from there. And so we're going to have that after his radio show. So Michael's agreed to, he has room for about 12 people. So if you want to register to Zoom in, we'll have that feature. And there's also room for 12 people. So Tom Henderson, I see you're on the call. We expect to see you there. Michael might even buy us lunch when we're done. So, and then the last thing that I want to talk about was our Spring Educational Summit. It's going to be at Trump Ferry Point. That is sponsored by one of our close friends, Foresight. And this year we have James Siekman, who's a short game expert. James is out in Omaha and then spends some time out actually in the Phoenix, Scottsdale area in the winter where Marty Jertsen is. And then, so James is going to do short game and putting. And then from Caves Valley, Bernie Najar, who's the Middle Atlantic PGA Teacher of the Year, works with a number of long drive guys, including world champion Kyle Berkshire, as well as some Korn Ferry and PGA Tour players. And what's good about Trump Ferry Point for us in the Met section is it's kind of central to Long Island because it sits right there at the base of the Whitestone Bridge. So it's easy access from Long Island as well is from Westchester and Southern Connecticut, just straight down 95 and you're there. So we're hoping for a really good turnout, and something that we're going to do differently this year, which I've wanted to do for a while, is that we're actually going to be outside teaching. I enjoy what we do indoors, but to me, teaching is best done underfoot, under grass, if you will, and not from a stage. So I'm looking forward to being outdoors. The first part of the morning will probably be indoors for some presentations. Hopefully it'll be very warm, April 25th. It's something that I had been wanting to do for a while, and I'm glad that myself and the Educational Committee could come to terms with this. So if it goes bad, it's on me. If it goes well, it's on the Educational Committee. All right. So that should be a lot of fun. And this morning, I'd like to thank Dave Tobin and David Barbarkel with Ping for arranging to have Marty Jertsen. Good morning, Marty. How are you?
Good morning. Doing great, John. Thanks for having me.
Always a pleasure. Marty's kind of a fixture here in the Met section, both from a playing standpoint. Marty's been here to Bethpage to play in the PGA, very accomplished player out there in the Southwest section, and vice president of performance and fitting. So what's always good about Marty is he has a lot of good information. He comes at it from the standpoint of the technology of being the vice president of performance and fitting for Ping, but it also comes by it from being a player. So I think it's always a good combination when you have somebody that can do and somebody that can share that. And Marty, I'd like to turn it over to you and talk about some of the new things that Ping's doing with your fitting systems.
Yeah, thank you, John. I appreciate that. Yeah, I definitely have some great memories. A lot of PGA Cup teammates from up in the Met section, and playing 4 rounds of Bethpage a few years ago was one of the funnest weeks of my life up there, and quite fun. So a lot of great memories, and I've been looking forward to sharing some of the research we've been doing at Ping. I think, John, you noted just that not only myself, but I think our culture at Ping and pretty much everyone who's designing the products that come to market are good and very passionate golfers and players. And even this is how the company started. Carsten Solheim, he had skin in the game. He was an engineer. He picked up golf. He was frustrated. He looked at it and he's like, this, we're not bringing the right physics into equipment design. And that kind of got the ball rolling. It changed the industry forever. And we're still doing that same thing today. Is trying to solve problems that are, if you can solve a problem that's personal to yourself, your own pain that you feel in playing golf, it's going to be beneficial for the entire marketplace. And so I think what's fun about my career and being able to work at Ping is I've worked, most of my career coming up has been on the design side. So doing all the 3D design work, but working on a lot of shafts, grips, head designs, driver designs. My last official driver project was the G410 driver, where I was the lead engineer. But I've always had a passion for this, kind of like a Venn diagram of, you want to have the best product and then you want to have it perfectly fit for you. And then the ultimate is to stand at the intersection of both of those things. And so I'm still certainly involved in the design and R&D research, but now I come into work every day. I work, okay, how do we optimize the club fitting and how do we build better tools for you, right? Because one of the other big motivations that I kind of like to bring to work every day is trying to make tools that are available to our tour players available right to you and to our end customers, right? And try to provide that leverage and to do it quickly so that the everyday golfer, they won't get access to all the tour bands and balls and all the launch monitor and 3D stuff maybe and force plate stuff that a tour player might get access to. But over time, but we can get them very close to that, right? And help give you tools that work in your in your fitting, teaching, coaching scenarios that can make your job easier, better, and do it faster, more accurate, deliver better custom service to your golfers. So we're excited today to go over, some fun research we've been doing. I'm gonna talk about a brand new fitting tool. It's an app or website. Some of you may have seen our announcement from it. Called Ping Copilot. So I'm going to talk about that. And then I'm going to go into a deep dive behind the curtain of some of our new product development. So it's not going to be too product pushy here, but it's going to be hopefully go under the hood and see how we did some optimization on some core fundamental physics principles of our new product design, which I think is quite fun. And then how to marry that to the fitting process. So hopefully my goal at the end of today is, you're going to have some great new tools that you can use in your fitting scenarios very quickly. And then you'll have a really fun, deep understanding of some of the R&D behind the G430 product, including a little update on, some of you know, I've also worked on the stack system. You guys had Sasha McKenzie on about a year ago, I think. And it's kind of variable inertia speed training. And what's fun is that we've actually been able to use the data from the stack system to help improve our driver designs, which I think is quite cool, using training aid data. And so I'm going to go a little deep dive into that process and what that looked like, because it's quite fun. And hopefully you guys will get some enjoyment out of it. And if we have time, depending on how we're doing on time, I'll go over some fun shaft research that we've been doing as well, but we'll kind of see how things are going from a timing standpoint. So let me share my screen here and we'll dive right in. All right. I think that's rolling. Share. Okay, I think we're rolling there. All right, I see it right there. Okay, so that's kind of what I talked about, is that we have a lot of fun tools here that we use with our tour players. We got Cam Champ in the putting lab. We got Victor Hovland in our 3D system. We got tons of Arcos on-course data, and I'm going to talk about that today as well, is how we've leveraged that data. It always sounds fun. Oh, we're going to collect all this data, but what do you do with it is the question. How do we use it? That is very relevant to how we optimize our new G430 iron design. We have some very fun tools there. Our master fitters, obviously our Ping Man robot, and tools like Ballnamic, which is our ball fitting software that we made, that is available for you as accounts. You can license Ballnamic and have access to it. It's brand agnostic golf ball fitting, where we test all the balls on the market. And what's fun about Ballnamic is that it decodes aerodynamic differences. So it's very interesting about golf balls, if you're measuring them indoors or on a foresight, some with initial conditions, is that driver spin rates on balls don't actually change initial spin. They don't actually change that much, but how they fly down range is very, very different. And so Ballnamic's the only tool on the market that has a aerodynamic model for every individual golf ball on the market. We just updated it with the new Pro V1s and some new balls that are on the market there. So consumers, your customers can either go through that, or you can license it from us and use it in your fitting environment, which is quite cool. We're not going to spend a lot of time on that today, outside of just noting that if you can't get somebody perfectly optimized in their driver or their irons, from some of our charts that we have and some of our new tools that we have, you can bring golf ball in and kind of supplement that. So we use that on the back end. Every fitting we do at the proving grounds and all of our fits that we do with our mobile fitting vans, the customers leave with the Ballnamic ball fitting. We don't think of fittings complete without marrying club and ball together synergistically. And balls are very different, and Ballnamic allows you to see what's going on aerodynamically with the balls, which is quite fun. So we do all that to help you, give you leverage and tools, kind of like I was talking about in your fitting environment. So that's our motivation. That's our journey today that we're going to go on. So this is that intersection I talked about of you want to have great product and you want to fit it perfectly, right? And marry those two things together. You know, if you have a weakness in either area, you have a great product design, it's not fit well, it's not going to be good for you. If you have a perfect fitting, but your driver's not forgiving when you miss hit it and have the variability around the face and face to path and dynamic lob variability and condition variability, it's raining, moisture flyers, that's not going to help you out either. So you want to marry those two things together. So brand new fitting tool, I'm going to jump right into a very fun new fitting tool that we just launched. So if you're part of our Ping Academy ecosystem, you probably got an email from us in the last week and a half, 2 weeks ago or so, with the announcement of a brand new tool that we have, which is a web app, and it's called Ping Copilot. So this is kind of like the transformation. The analogy I kind of use is the transformation that took place during COVID. Restaurants had menus, and now you go there and you QR code it, and you got all your options right there on your, on your phone, and you're looking at them. That's kind of similar to this transformation we're making here with Copilot, which is we've had a lot of traditionally produced a lot of like 2D static charts. You know, our color code chart, the most iconic one in golf, and then we've launched things like you see up there, our driver optimal launch and spin chart. This uses an impulse momentum model, and hopefully all of you are using this. It's cracked the code on the importance of angle of attack in your driver fitting. And so we've launched that one. We've launched iron spin rate guide, 7-iron landing angle guide, junior fitting guide. All these things have become more nuanced and more complex, especially as we've added different iron models. Now we have 6 or 7 different iron models in our line. They all launch and spin differently. So we kind of got tapped out a little bit on how much we could do with delivering these charts to our account. So we've had some fun tools internal here at Ping, at the proving grounds we've used with all of our customers that have come in to get fit. That's really fun, like software, apps, and widgets. So Copilot is finally being able to deliver that right to you. You can use it with your customers. Okay, so Copilot's a web app, and I'll talk a little bit, John and folks, how you get access to it here. But it's a web app. You log into it, and it works really good. It's optimized on a mobile device. That screenshot there is on a phone, or if you have a fitting studio or bay, big screen, you can show it on indoor, outdoor bay, indoor only bay. You can just have it up on a web browser, log in, and it works great on a big screen, and it scales down really well on a mobile device. And what Copilot is, it's why we branded it Copilot. It's meant to be right there with you, as you're the chief pilot when you're fitting and coaching your customer, right? And it's right there with you to help answer questions for you, make your job more efficient, help you along the way, along the journey, right? And so that's why we branded it Copilot. So what it is a collection of both static charts, but more importantly, and I'm going to jump around and drive around a few of our apps that we have in there. It's some applications that will help you optimize your player in different areas, which is really fun. So I'm going to jump in and head over here. Let's see. I think you guys are seeing that at this point, our web browser here. So it's Copilot, pinkcopilot.com. And as I said here, it's a collection of static charts over on the left here. We got important catalogs and links over to the right. And right here in the middle are what I think is really fun. So we have things like I don't want to call it basic or simple, but let's say you have a new club fitter at your course, and just using our color code chart gets a little much for them. You know, find the intersection of height, wrist to floor, and how to read and interpret the chart. You can now go into Copilot and put in the height and wrist to floor of your golfer. You hit get color code, and we will just chart where the player is right there on the chart for you, for your club fitter, and give you the length and color code recommendations. This is probably like our most basic use case here from an app and widget standpoint, but certainly enjoyable. This one is very relevant to our G430 product line, and I think is one of the toughest challenges that probably each of you face out there is how to build the right set configuration for your golfer. Okay, I fully realize we're providing you a lot of fitting tools in the driver. We provide you a lot of fitting tools with our AFS system, or from our competitors, you got 7-irons you're fitting with, right? So from us, you got 7-irons you're fitting with. You can spend a lot of time fitting the driver. You can do quite a bit with the adjustability of our fairway hybrids, and now even our new crossover, iCrossover has adjustable hosel design to use. But let's say you want to do a full bag fit for your golfer. Driver's kind of its own thing. You kind of optimize that on its own. It's its own animal with its own goals we'll talk about there. But let's say you have a golfer in and you want to fit him for a 7-iron. Hey, here's Ping. We just launched a new set design. You might not know the exact loss or how they gap, or we added a new wedge in the bag. That might be, intimidating you, or why is Ping doing that type of thing? How do I build the bag of the golfer? I think it's one of the biggest challenges each of you face. And I really wanted to help solve this problem for you in our team here. And so how we did is we built this widget for you where you can go in and you're going to find this theme from us. And I would encourage each of you as fitters and coaches, what you see from us at Ping is to start knowing the golfer's 7-iron launch conditions off the top of your head, just like you know their driver launch conditions, right? So I know my driver launch conditions. If I'm fully warmed up, 175 to 178 ball speed, I launch it at 12.5 and my spin's 2,300, right? Everyone kind of knows their ball speed, launch, and spin. I think it'd be advantageous to also start knowing your golfer's 7-iron ball speed, launch, and spin. And the reason why is we can use that to help drive. We use it in Ballnamic to drive ball fitting, and I'll use it in some other tools here that we have. And we have some great guides I'm going to show you on how to understand what is a good ball speed, launch, and spin, or what's the goal? Like, what is a good spin rate in a 7-iron? Is one other dilemma and problem we want to try to help solve for you. So we're here in Copilot, and this is our set makeup widget. Let's say you're fitting your golfer to our new G430 iron, and you can either put in their 7-iron. So you put in 7-iron, your AFS fitting club here, data. You can either put in swing speed, our default's carry distance, super easy, or you can do ball speed, right? So let's say you get your golfer in. They're carrying their 7-iron like 130 yards. Their current trajectory is low, right? You can click here. And we have some great set makeup charts, but this is taking it to the next level, making it much more advanced, much more nuanced here. You can click here, and we're going to give you 2 recommendations for set makeup for this golfer. We're going to give you a higher flight bias set recommendation, and we're going to give you a mid, right? And that mid might be more, hey, firmer or softer conditions. Maybe you have, or more rollout, windier conditions, you pick the mid flight, softer conditions, elevated greens, less wind, you pick the high flight, right? or that's kind of the interview process with the golfer. So again, this is that ultimate co-pilot. It's kind of right there with you, but it's giving you help with how to make some of those decisions. So we got a 5-wood, 7-wood, 5 hybrid, 6 through pitch, and 45-degree wedge, right? And that's our new wedge, that we have there in the G430 line. We added another club to the bag. I'm going to go through the background of exactly why we did that, why it was time to make that that transition this year. Okay, so that's quite fun, and it also gives you target launch conditions for your player when you're fitting them for a 7-iron. So I can go back and do another scenario. Let's say we're fitting a player into I-230s, and I'll do my kind of scenario here. I'll do my 7-iron. Ball speed is about 130 miles an hour, right? And my ball flight, it's probably between mid and high, but usually I would say by default, I would say it's kind of high. And I can hit get set makeup here. And we give a high flight recommendation, which is 3-wood, 3 hybrid, 4 through pitching wedge. That's usually what I play, right? If I go to a place where I need to hit windier conditions, let's say PGA National Championship last year in Austin, I was hitting some 2 irons off the tee or 3 irons off the tee, I-500 3 iron off the tee. I played the mid-flight set configuration. And my spin rate range, I usually spin my 7-iron like 7,300 stock. So that's a good spin rate target range for me, right? So this scales really well. It doesn't mean that you have to fit your golfer to that particular set recommendation. You know, maybe our goal here is, 80% of your fits fall somewhere in one of those 2 windows. Obviously, sometimes the app might give you a 3-wood as the lowest lofted fairway wood. It might actually be a 5-wood for your particular player, right? So I think that 3-wood, 5-wood decision can be something you custom fit. But we think this is super helpful. Hopefully each of you can explore and use this in our new Copilot tool to make those decisions, especially, we'll do a slower ball speed here again in the G series or I-525, especially when you're trying to determine that what is the longest iron this golfer can play, right? And you don't have the clubs there, or maybe the golfer's tired. You don't want to have them hit a bunch of 7-irons, then have them hit 5 irons or five irons and 4 irons and in a 5 hybrid and a 4 hybrid and a 7-wood and 9-wood. Maybe that might take too long. The player's tired. You want to economize your time. How do you determine that? And so we built this tool to help give you that determination. The way this tool is built, it's kind of built with kind of like AI is kind of a term that's overused a little bit in the world, but it is kind of an AI tool in the fact that we use all of our fits we do here at the proving grounds and on our mobile fitting bands, feed the algorithms of this data, right? So it is actual real life testing combined with ball flight modeling that we have as well in marrying those 2 things together. So I'm super excited about this tool. All of our fitters at Ping use this 100% of the time when you're doing a 7-iron fit, because the question is, okay, how do you build the bag, right? And this can give you a really good jump start, make that process very, very, very efficient. So that's a tool that we love. And again, we try to make the complex simple here on the design of it. And I'll jump back into Copilot again here. And another fun one we have, this is kind of a lookup table of our driver optimal launch and spin chart. So this is driver launch conditions. You can go put your ball speed in here, your angle of attack of the player, and you get your target launch and spin for that particular golfer. Okay, so this is very basic. You want to choose camera based, which is obviously primarily foresight for most of you folks out there, or radar based, which is primarily TrackMan or Flight Scope, X3, X2, that type of thing, because they're going to read. The reason why that's important is that we've talked about this probably a little bit in one of the previous sessions, is that camera based and radar based read the location of the angle of attack of the driver differently. So the radar based will try to pick the middle of the driver, and the driver's coming into impact, and in the middle of the driver will be going more down while the face is going more up. So there's usually approximately, it changes over time, about a 2-degree difference in the way a face fiducial solving for the plane of the face delivery and a radar base will measure angle of attack. That's why it's important. So we've kind of built that into this widget. So that's a very simple widget to find driver launch conditions. The one that's most used, we've been tracking all of our fitters out there, how much they're using all these different widgets. And this is the most popular, launch efficiency. And our fitters love this one as well. So this is, you're trying to optimize, let's say you get your golfer in, you want to optimize their driver launch conditions. Okay, that's your goal. So we would use this 100% of driver fits. Player comes in, we're fitting them. You can answer this question for them. Are their fairway conditions soft, moderate, or firm? That's going to kind of help us optimize landing angle, obviously. Are you using a camera base or radar base? Just talked about that. We got some little helper text in here again on that front. And then you put in the player's ball speed, launch. Let's put in 173 ball speed, 8.5 launch. Let's see. You get them in here, their 3150 spin, their angle of attack is up 2.5. And you can even put on side spin in here. I'll go back, I'll kind of show why that's kind of important. And then you can put on the temperature and altitude of your golfer, because that matters from an environmental standpoint. And we kind of feed that into our ball model.
Marty,
then,
are these actual numbers coming off a launch monitor that you're putting in?
Yeah. Yeah, you put in kind of actual launch monitor numbers right there. And you'll get this really cool chart here called launch efficiency. And we came up with one single number to describe how well the golfer is fit from an optimal launch and spin standpoint, right? So your target launch for that ball speed angle of attack is 11 degrees and your target spin is 2550. So what's happening when you input that data is we're actually using an impulse momentum model of the driver smashing into the golf ball. And we're running all possible combinations of dynamic loft delivery and what the resultant impact is on the trajectory for those specific environmental conditions. And we're solving for what's going to maximize distance, which is the easy thing to do in a driver. And then this is really cool. This is your co-pilot AI tip, is recommended adjustments that you make as the fitter, right? So it's like, okay, boy, I need to get the launch up because it was 8.5, I think I put in there. Yeah, I need to get the spin down. And my potential gain from fitting only, my potential distance gain for the golfer is 8.9 yards. And we even give little tips and tricks on what specifically you can try to do in your fitting, right? So try hitting a little higher on the face. If contact's already centered, consider teeing it higher and or using a lower spinning head, right? So you're instantly more intelligent here, and you have your co-pilot here to help tell you tips and tricks and nudges along the way. You don't necessarily need to use those, but certainly that could be helpful to some of you. Or again, I think this is an amazing tool. We're just training a class of new club fitters here at Ping, and this has been absolutely phenomenal to help give that feedback loop on what exactly to do. So you can think of this as a collection of tips and tricks of our best fitters here at the proving grounds, and it's driven through modeling. So this is quite fun. I talked about side spin. Now, why do we put side spin? Let's say somebody had a lot of side spin on their tee shot. It get launch efficiency. The reason why this takes a while is it's running tons of simulations. So we're using a lot of compute power to do this. And now we say we have potentially 20 yards to gain. So why? I didn't change anything else. I had like 9 yards to gain previously. Now I have 20. Why is that? The more you curve the ball, the shorter you're going to hit it. So that's the conclusion here. I know there's like a debate going on in the world of curving the ball versus hitting it straight. But for your everyday golfer, hitting it straighter is a very low-hanging fruit to helping your everyday golfer hit it further. So we've seen no fundamental physics-based reasons to try to just zero out your face to path and zero out your curve. We think that's super beneficial because the gains you'll have in distance will outweigh any losses you'll have there in directional dispersion. We've kind of run that through strokes gain analysis here with kind of methodology based. I know you had a session with Mark Brody a few weeks back, or using the methodology based in that he laid out in the core definition of strokes gained in his book. So that's a fun tool, because if you have a golfer curving a lot, now you can show them, okay, if I get your curve, if we can minimize your curve, get that back down to 0, you can just show them with the data how much distance you can gain by just hitting it straighter and curving it less, right? So that's kind of like a little subtlety of this app that I certainly enjoy, and certainly enjoy talking about. It kind of gives you that proof. Now you got 8.9. I go to some different scenarios in the app here from a launch efficiency standpoint. Let's go to your golfers. 125 ball speed. They're kind of launching it at 10. Let's say they're spinning it at 1600 neutral angle of attack, and we go boom. You probably don't have a lot of folks in the Mets section that you're fitting for different temperatures and altitudes, but that's certainly fun to play around with as well. So this is a terrible scenario here. This golfer, lower ball speed, your target launch is 13.5 and your target spin is 2700. So they're launching it too low and not spinning it enough. So it's like screaming more loft, right? And so there's some kind of end ranges on this app. Again, our fitters that have been using this so far have absolutely loved this launch efficiency tool. And this is for drivers. Later this year, or probably by this summer, we will launch this also for fairway woods, right? Because that's another question we get asked that nobody's really cracked the code on. If your goal is to maximize distance in your 3-wood, what's optimal launch conditions? I think if we asked all of you and did a survey here, hey, what's the perfect spin in a fairway wood? We'd all have kind of different answers. It might be variable depending on the conditions and things of that nature. We're going to crack that code in a very fun way. And a fairway wood is unique because you need to optimize it. Are you optimizing it for tee shots, or you optimize it for off the ground, or you optimize it for the blend of both? And our app that we're building will have the optionality, give you the optionality to kind of look at fairway woods either way. So that's a fun one. Launch efficiency. A couple others I'll show you real quick. Obviously, we got our grip size chart, very basic one. WebFit Junior. So if you're fitting kiddos for our Prodigy product, we have a fitting chart out there, but again, candidly, it might not, if you're not using it every day, it might not be the easiest to go, find the intersections and figure out what shaft and length and color code for your golfer. This one's super simple, but very effective. I use this when I'm consulting on build specs for all my friends who have kiddos here. You put in height, wrist to floor, driving distance of your junior, and we spit out a full set recommendation for our Prodigy line. So driver, 5 wood, 5 hybrid, 7, 9, U or gap wedge, sand wedge and putter, larger bag, green, which are stiff flex shaft, orange color code. We give you all the lengths right there as well. So this is super, super convenient. What we do, which is quite fun, is if juniors hit the ball shorter, we start recommending way less clubs, right? So driver, 5 hybrid, 9 iron, sandwich, putter. That's what my kiddos use. That's all they need when they only hit their driver, less than 100 yards, right? So that's kind of a fun one that's in there. And then this Copilot also acts as your one-stop shop for all of our core fitting charts. So if you still want access to our charts, you want to print this out. Here's our driver optimal launch and spin chart. We did kind of brand this in our G430 color palette here. And with this, you notice, which was a legitimate request now, is that our previous chart we had only went to 180 mile an hour ball speed. We're seeing so many players out there have higher ball speed than that nowadays. We had the numbers to support Cameron Champs of the world and Wilcos of the world, but we expanded 2 more rows on top of the chart, 190 and 200 miles an hour ball speed. So that's in there. Our shaft comparison chart lives within there, super helpful. Optimal set makeup. So this chart here is basically been replaced with that widget I just showed you. So you don't need to use this chart anymore. If you like having charts printed out, if that's better for your environment, you can go ahead and use this. Find the intersection of spin and launch conditions in your 7 iron, and whether you want your golfer to or whether your golfer is low trajectory, mid trajectory, or high, and you can find this intersection point. So that's certainly an option, but hopefully each of you will be using the actual widget over here, set makeup widget. This is kind of a fun one, which I think we've tried to answer this question of like, what is a good 7-iron spin rate? You know, we solved this for drivers, which is to try to answer that question of, you know, what is optimal launch conditions? We cracked the code on that with the optimal launch and spin chart. And then, you know, a lot of folks like yourselves asked us, well, what's perfect in a 7-iron? If your goal was to maximize distance, it would just use the driver chart and hit a driver, right? So it became more complicated on how to answer that specific question. But what we did is we data mined a bunch of 7-iron spin rate data, and we built 3 different bands into this. So this is a chart of club head speed versus spin rate. And it can at least be a guide for you to say, okay, with the 7-iron, what's a reasonable range, and does my golfer live on the low end for their club head speed or on the high end for their club head speed? Because speed, as you can see in this chart, as well know intuitively, and we know from the physics of it, speed drives spin rate. And so a higher speed player, they're going to have a different kind of spin range for their 7-iron than a slower club head speed player. This can just be a nice little guide for you on that front, if you want to kind of address that topic by itself, right? We got a few other charts in there. Yeah, all of our wedge grinds live within Copilot. And certainly this is just the beginning. We are going to keep adding more and more tools right here into our Copilot app, which will be quite fun. I mentioned we're going to have a fairway wood optimization. And I'll give you a sneak preview into another tool that we're just finishing our testing on. This is a very advanced version of that set makeup. We call this our gapping app here. A very advanced version of our set makeup, where you go in, you choose the iron ball.
To another golfer. We do that in the swing eval all the time, but that doesn't mean that he did a fitting for you and told you, oh, this is what you need.
We're using G4. Let's say you go in here, you're picking G430 irons. Player ones. This is always the classic questions you got to ask as a fitter. Well, how many wedges do you want to kind of build their bag and optimize their gapping, right? Let's say you're going to fit them. You can either choose set wedges, or you can choose our specialty glide 4.0 wedges. You want, maybe 2 more wedges. You want the highest lofted wedge to be a 58, the lowest lofted fairway wood to be a 5 wood. And then you start putting in here, do you want to power spec them or retro spec them? So we can do standard here. You can put in, again, I mentioned that 7-iron ball speed, launch, and spin. So let's go in here, say 103 miles an hour, 16. Let's bump the spin down to 5,000 range, 5,200 range. You put in temperature, altitude, course conditions. Let's put in medium. And then this is quite fun, is we actually build and simulate the gapping throughout the whole bag, and we solve for the lofts and set configuration that are going to give this golfer very even gaps throughout the bag with some optionality. Now, we've given a set recommendation of 5 wood, 4 hybrid, 5-iron, 6-iron, 7, 8, 9, wedge, 45, 52, 58. We've put all the carry distances in there for all those clubs, and you can actually go in here and do a virtual what if. Well, what if we call this the swap zone. What if I traded that 4 hybrid for a fairway wood, right? So you can go in here and trade that out, and now that's changed to a 9 wood, okay? So you can go in here, you click this, again, you'll get these options. And there's there is exactly what would happen with very high probability of how that golfer would hit a long iron, a hybrid, and a fairway wood that tried to kind of solve for the same total distance. That's what you'd see in those trajectories. And this tool gives you this ability without the golfer having to hit these clubs. Now, that might sound crazy. Well, I need my golfer to hit these clubs. Again, I kind of go back to, you don't always have time. they might be tired. You don't have time. You might not have the hardware tools, right? You might not have their specs and their fitting tools to do this. So now we can do it virtually. And what we found is that this thing is so accurate in our predictive modeling, you can actually spend more time getting the driver dialed in, more time getting the 7-iron dialed in, lean on this tool to do your set configuration for your player. Quite phenomenal. So you can simulate all those, how that fit in throughout the whole bag if you wanted to. You can get comparative differences on what the hybrid would do from a carry and a peak height standpoint, which are the core things hopefully you care about with your particular golfer here. So we're just putting the finishing touches on this app. This will probably be the most powerful app that lives within our Copilot tool. You can even download a gapping report at the end that has all their gaps for your player. A lot of people struggle. They don't know how far they're going to hit their clubs. So now you can imagine a world golfer comes in, you fit them for G430 irons, you build their bag perfectly, you get really good drop, you get really good 7-iron numbers, you plug them in here, you build their whole bag. Now you can give them load a report, give it to them, and tell them exactly how far all their clubs in their bags will go, right? With very high probability, they'll be pretty accurate as long as the data you input into the app is pretty accurate. Yeah, so we give you this kind of table here of carry, total, land angle, and gapping for all the different clubs in the bag. So yeah, super excited about that. That'll be coming here in the next probably a couple months. Hopefully that'll be live in Copilot by this summertime.
Marty, we had a couple questions here in the queue that I'd like to
Absolutely
have you address for us, please. So let's say I'm a golf professional or a fitter. How do I go about accessing the usage of Copilot?
Yeah, great question. So to get access to Copilot, you'll need to be part of our Ping Academy LMS education system. So if you're not familiar with it, this is how we do all of our education to our accounts and certification, right? Our fitting certification. So if you want access to it, we'll send this in our follow-up email as well, John, but you go to edu.ping.com. If you're not part of Ping Academy, and register for Ping Academy, and we'll send you an email with how to get access to Copilot. You have to go through a little course that kind of gives a little bit of training on it. And then once you go through that course in Ping Academy, we send you information on credentials and off you go. So edu.ping.com, and we'll follow by email with those instructions as well.
And then, so by doing that, then if I were the individual doing that, then I also get an education so that I know what I'm talking about.
Exactly. Yep.
That's always useful, right?
Mm-hmm.
And are all this information, are these going to be on the app, so we'd use them on our phone or our iPad?
Absolutely. Yeah. So yeah, this is called a web app. So it is an app, but it's just a website. So you can access it from any device. All you need access to the internet, phone, iPad, computer, anything.
Okay, so then I can use my laptop as well. Good.
Yep.
And then probably Tom Henderson here does Copilot apply to putter fittings?
Good question. Yeah, right now we still support and use our iPing putter fitting app, which is taking an iPod or your phone, any iOS device, using one of our cradles. If you need one of those, you can loop in and through David or our team there, and we can get you a cradle, or we can have that in our follow-up, John, as well, if anyone needs access to cradles. And it uses the accelerometers and gyros in the phone, combined with intelligent algorithms, fitting algorithms, to give a model specific, and we have a full catalog in there, putter recommendation, right? So it uses things like, we know that fundamental research that a faster tempo player will putt better with a lighter headweight putter. We know from a lot of the kinetic and kinematic science that if you rotate the face more, you generally would do better with a more toe down putter, strong arc putter in our vernacular here. If you miss putts to the left, if you play a more toe down putter, it will dynamically deliver the face more open to path, and you can bias a miss tendency with putting. That's all built into our iPing 2.0 app. That said, we have talked about potentially adding a putter fitting kind of guided thing into Copilot, but we really like that the iPing uses the sensors to get really high fidelity stroke type data. So for now, we'd still use iPing 2.0, and we'll include that in our follow-up email as well. Access, how to get access to the app, and if anyone needs cradles.
That'd be great. I have a question about that as well, but I want to get back to that. I want to finish Tom's question here. So then the other question he had relative to that was, how do you deal with loft and putter heads when you're doing your putter fittings?
Yeah, loft. So yeah, general philosophy there is we're trying to kind of you're trying to find that sweet spot of skid to roll ratio, and we're trying to optimize for that. And you want to have a really good dynamic delivery tool. And so we've kind of leaned on iPing 2.0 because the sensors are super good in there to get really good shaft lean at impact. And that correlates really well with our dynamic loft delivery in the research that we've done and we've seen. And then you want to consider the surface conditions of the player's putting on, and kind of bias the loft either up or down based on that. And then we kind of generally have kind of agreed with what kind of Quintic's findings are from a launch condition optimization standpoint of a skid to roll ratio, approximately 10%, somewhere in that range is very functional. And so that's been our kind of general philosophy. So if you don't have access to measure those initial putt launch conditions, you can use putter dynamic delivery as a really good proxy for that, right? It gets you like 90% the way there if you don't have access to a Quintic, or, I know TrackMan is adding some nice stuff. Hopefully Foresight will be adding some good capability in the putter fitting world to get launch conditions. But if you don't, you can lean on dynamic delivery of the putter, right? Using iPing or even a tool like Blast, or there's a bunch of other tools that do a really good job at dynamic delivery. Is that kind of the question there, you think, John?
It is. And the age-old statement about acceleration when putting, right? I mean, we hear it so much, like he decelerated. And just to share with you, I do a lot of putting and green reading, and I have a special tool that tracks acceleration.
Yes.
Okay. And so what I have found, and I'm not saying I'm right, but what I have found is, and I've had a number of tour players on this machine as well, and I have their data. I have found that the acceleration of the putter halfway down on the downstroke seems to be maximum speed. And then from that point on, if it maintains it, then it's in a state of deceleration. You following me?
If it maintains what?
If it maintains a speed that it's, if it reaches maximum acceleration rate,
yep.
And then from that point on, if it just maintains it, it's no longer in a state of acceleration. It's just maintaining what it's already achieved. It's not accelerating, it's just kind of neutral. And so I always tell people that, my data anyhow shows that people are not accelerating the putter head into the golf ball.
Yeah.
What do you find?
Yeah, John, that's a great question. So I've thought about this topic a lot. I think I would generally agree with, I think, your findings there. I look at this both theoretically and then practically, right? And if those two things marry up, it's usually a good thing in golf. So the theory of it is absolutely right. If you acceleration, the physics definition is the change in velocity over time. So if you're accelerating your putter, and let's say, and one of the things that's being talked about a lot, we've tried to research this, the concept in full swing of a 3D flat spot, right? Chris Como's really helped a lot of his golfers, helped Tiger Woods with this. Thank goodness he's back, and Bryson obviously is kind of using this concept of the 3D flat spot, which is how do you create that geometry that's going to give you a lot of forgiveness down there near the impact event, so that you, the reason why I'm talking about this in full swing is that I think about acceleration and putting very similarly, where let's say you don't get your ball position perfectly, but you still want to have really good distance control. So let's say if you have a high acceleration, if you're accelerating into the putt, you're changing velocity over time, and your putter head will be changing velocity. If your ball position is a little bit off, you play further back, you're going to hit it with a lower club head speed. You play the ball 1 inch further forward, you're going to have a much faster club head speed. So I totally agree that you in theory, you should have a zone where you have zero acceleration. It's not negative acceleration, zero acceleration.
Correct.
Zero acceleration is the same velocity in some zone if you're not accelerating it. Then obviously you see a lot of great putters. I mean, Max Homa is the latest one who's putting amazing. His backstrokes this long, forward strokes this long, or Sahith on our staff, he recoils his putter. He ends his putt back where he started his backstroke, right? So you see all these great putters do that. That's probably what they're doing. And then once the putter head hits the ball, you obviously have the momentum transfer of the mass times velocity of the putter, puts an impulse on the ball moves, and then that slows the putter head down, which is why you have visually a shorter follow through than backstroke. So that being said, John, this is a complicated topic because Sasho has looked at acceleration rates of different golfers and putters and has found that there's not necessarily a tie to consistency or more putts made. That's not the final conclusion to say, sorry, and the putter is good or bad. I lean on your evidence and what you've seen in both the theory that it's good to have a zone of zero acceleration, which means constant velocity of the putter to give you more forgiveness to control your speed better.
Right. And one of the other things that I see a lot of is a lot of the better putters on tour, and you mentioned Max, who has just been off the charts lately. Is backstrokes are much longer, as you mentioned, than through strokes.
Oh, yeah.
And I've come up with a ratio that that I work with. Not to say it's the ratio, but it's a ratio that performs well. And anytime I can get backstrokes longer than through strokes, then I seem to be able to get a better energy transfer from the putter head into the golf ball, and I get a better roll. And people, when this happens, people just look at you like that was solid, right?
Yeah.
It's not a feeling that they're accustomed to.
Yeah, Stan Utley is one of our engineering ambassadors, and he has folks putt and recoil or hit the putt and drop the putter. I mean, those are just great things if you have somebody over accelerating.
Yes, very good. Thank you, Marty. Let's continue.
Yeah, so this Copilot tool, we'll keep building more and more things in here. And again, fantastic tool. I encourage all of you to use it. Make your fitting environment better and faster. I mean, I've certainly leaned on this tool quite a bit over the years. So that's Copilot. And I'm gonna kind of go into how it kind of weaves into our G430 product and how you can use Copilot, and also go a little under the hood of some of the R&D behind the G430, which I think is quite fun. So our new G430 line, I'm sure many of you have seen it, was for amazing gains in every product category across the board. Actually having a little bit more time through COVID allowed us to kind of do some more optimization, squeeze some more technology into the product line, which is quite fun. Just amazing performance gains across the board, whether you're LST player, max player, SFT player, phenomenal gains. And I think that some of the product tech on the G430, it's the thinnest face design we've ever had in a driver, which is quite fun. So the face is a little shallower, the head's more aerodynamic in that way, so we're getting a little more club speed. And then we're getting more ball speed at the end of the day. That's the goal that we're after. And what's really fun, and I'm going to talk about today, is this technology you may have heard us talk about in our marketing stuff called spinsistency. And what that means is that we have a face design that gives you more consistent spin, okay? And why is that important? We all know, I actually think a little bit, this might be a little hot take here, but finding the center of the face on your driver is a little bit overrated now, because we have technology like spinsistency and the moment of inertia on our driver is so high. I have actual evidence of this. When I was at the Shriners event, we launched the G430 driver, and our players can now hit the driver thin. And we're at TPC Summerlin into a little crosswind in off the left. Player thins the driver, right? And they're all trying to swing really hard out there on the tour now. Thin the driver, they're like, oh, you kind of have this reaction like, oh no, it's going to peel up and wind's going to take it. It's going to go, I'm going to miss the fairway over to the right or whatever. They look up and the ball flight did not rise. It didn't spin. It didn't spike it spin. It didn't balloon up into the wind. Didn't go, just barely peeled off to the right. Not that much. They look at the launch monitor. Their normal spin when they hit it perfect is 2,400. They just thinned it. It was 2,550. Normally it'd be 2,900 or 3,000. And they're like, whoa. So what do you do if the driver is way more forgiving like that? These guys start swinging harder, right? Now you don't, whether you like it or not, you don't need to hit the middle of it. There's less of a priority on hitting the middle of the face. So I actually think this is groundbreaking in that way, that now you can swing harder. Our tour players are 100% doing this. They told it to me. I saw them do it right there at the Shriners event, is that now you're hitting that T-ball into the wind, into the crosswind, whatever. You can thin the driver and the spin doesn't rise. And I'm going to show how we did that. You can showcase this with your golfer in your fitting environment. I'm going to show you how to do that as well, which I think is really cool. So hopefully this session, I've kind of taken, hey, you've seen this from our marketing stuff. Here's what it really means to you, how you can showcase it to your golfer, and how we did this technology. So we talked about our driver fitting tool on Copilot. I mentioned a model called the impulse momentum model, and that's just the ability for us to do simulations on the computer that would take us years or decades to do with our Pigman robot making prototypes. That's really what we're doing. We can take a face design, change the properties of the driver, smash it into the ball, smash it into all the different types of balls on the market, throw wind at it in all kinds of directions if we wanted to, and simulate the results downrange. And we can do that with computer superpower and modeling capabilities. That's how we optimize the face curvature on the G430 driver, which is really cool. And it makes it way more forgiving. With the change in bulge and roll contouring on the driver, it's as effective as if we would have been boosted the moment of inertia by 20%, right? So imagine we would have to launch a 500cc driver to get that level of moment of inertia increase. So there's different ways to get forgiveness for your golfer. It's not just all about moment of inertia. That's kind of our staple thing of Ping. Carson brought that to the market, but there's other ways to do it. And consistency, I'm going to kind of go into the deep dive of how specifically we did that with the G430. One thing, if you haven't hit the 430 yet, I think most of you or a lot of you have, is it sounds amazing. We did a lot of, again, numerical simulations here to strategically increase the stiffness. So some of the science behind it, you see these frequency amplitude charts here, is you actually want to have like a higher peak at a low frequency that gives you that deep, thuddy sound. And then all of the kind of noise in the high frequency that maybe is less desirable in a driver that doesn't sound as good to you. We've kind of toned that down. And you also want to pair frequencies together. That's using a little bit of music theory, right? In music, if you pair frequencies together, that's very pleasing to the ear, right? So we kind of have a higher amplitude in a lower frequency, gives that deep sound. And then the sound, I think we can describe it. You hear golfers describe it as very like clean, right? So there's not a lot of strange like resonance going on. This is the case whether it's the LST, the Max, the SFT. Our fairwoods and hybrids also phenomenal in terms of the acoustics. And it's just fun that we were able to kind of do that optimization. So if you cut the driver open, you see a bunch of really cool ribbing in there that's took a lot of a modeling capability to do that. We brought in this little nod to the Rapture, our old Rapture driver, but this carbon fly wrap on the LST driver. And the reason why we have them on the LST, the priority is to get the CG low. So we get the spin low, so you can optimize your launch and spin for your player using our Copilot tool, right? So we still have our core stable models, SFT. What's new about the SFT is we have the draw position, and then we have the draw plus. So now we're providing left-right bias optionality in the SFT, which I think is quite fun. The Max, mega high inertia, over 10,000 combined top, bottom, heel to toe inertia. And then the LST, absolutely phenomenal in terms of low spin, but still mega forgiving, right? Mega stable when it comes to spin. You can still use the CG shifter. It's right around the perimeter, keeps the moment of inertia super high. One important note on that is that the LST CG shifter doesn't move the left right as much. We found that we were kind of overkilling it for the better player, of like the fade position was moving the ball flight too far to the right from a face to path delivery and gear effect standpoint, and the draw as well. So we kind of brought those in a little bit, about 30, we brought them in about 30% relative to previously. Still use our same trajectory tuning sleeve. So nothing new on that front. So yeah, just fitting powerhouse. You're going to see high ball speeds, consistency. I'm going to talk about that. The sound, optimize the launch and spin, curve it less, use the sleeve. We got a new HL build I'm going to talk about, shaft fitting, and then you know, that with that concept where you want to prioritize gaining the golfer distance in the driver at a ratio for your everyday golfer of about 2 to 1 relative to accuracy, right? So your everyday golfer, if they gain 10 yards, they can live with 5 more yards offline, and that's a break even from a strokes gained driving standpoint. The tour player is more 3 to 1. If they gain, let's say 9 yards, they could live with 3 yards offline, and that's a strokes gained driving break even. So as long as you gain 9 and your dispersion doesn't grow more than 3, it's a win from a strokes gained driving standpoint. With the exception of a course like Honda, ironic, we're doing it this week. That's the toughest driving course from a penalty standpoint. So there you want to put more of a premium on accuracy than distance. Obviously, there's other courses where not as big of a penalty from an accuracy standpoint. So to get your
Marty,
golfer, yep, John.
Okay, a question about your driver head.
Yeah.
I've always been impressed with Ping drivers because it doesn't matter who you put on that handle. Ping seems to make a driver for everybody, and people that can't hit any other driver always can hit some kind of Ping driver. So you guys have done a really good job there, you know, over the years. The driver head itself, when you're standing there at address and looking down on it, you have those little ridges right at the top of the face.
Yep.
Are those aerodynamic ridges?
Yeah, great question, John. Yeah, those are called turbulators, and it's quite fun. The story behind that is there was a gal who won a gold medal for England in the Winter Olympics. I forget what year it was, and this was in the skeleton event. And I don't know if any of you have seen that skeleton, but it's like a downhill bobsled type event on a sled. You're going down head first, and she had this helmet with little ridges that were angled back and forth right at the top, and it was kind of a little controversial from a rule standpoint in the Olympics. But what those little ridges did is they actually created a micro section of turbulence that gave the air momentum to kind of stay attached to the helmet. And we prototyped that on a driver design. That's kind of where we got the idea, and integrated into our driver. Our first driver we had is the G30 driver. And we did all the optimization down in the wind tunnel here at Arizona State University. And now we have the ability to do aerodynamic simulations numerically on the computer. But yeah, those make the driver, they give the airflow more momentum to stay attached to the crown, reduces the vacuum effect, because if you didn't have it, a driver would be like a pickup truck. Like you have with the bed open, you have this air circulating in the back, acting like a vacuum, literally sucking the driver backwards, right? So there's 3 forces acting on the driver: the gravity, the force and torque through the handle, and then the force of drag, right? And so we want to reduce that force of drag, and in doing so, we can get I call it free, because it's independent of having to make the driver smaller in head volume. So the driver goes as fast through the air as if it were like a 340 cc driver, but it has the inertia of a 500 cc driver, right? And that's innovation, is be able to kind of crack the code on that. So that if you didn't have those turbulators on there, John, the driver would go, for a fast swing speed player, 1.5 to 2 miles an hour slower club head speed.
Interesting. Thank you.
Yeah, great question. Turbulators.
I need turbulators on all my clubs.
Exactly. The driver's the most important because A, the head's the biggest, and B, you're swinging it the fastest, right? So there's major priority on the turbulators on the driver. Okay, yeah, talked about that a little bit. So I'm going to talk about the face curvature design and how we did that. This is applicable across all of our G430 metalwoods, driver, fairway, and hybrid. We can now have better optimization of the contouring the face and how it works with synergistically with the properties of the head. So obviously everyone out there kind of knows the basics: bulge, like belt, heel toe, curvature, roll, top to bottom, curvature of the club. And we use this as designers to offset the effect of the gear effect, especially for deep center gravity clubs, right? So as the center of gravity is back, you get this, and you hit it off centered impact, you get this shearing effect that changes the spin and launch, but you get that shearing effect that puts spin on the ball. And for heel toe impacts, side spin, for top bottom impacts, a reduction in backspin. Okay, so as if a center of gravity is close to the face, you don't get that shearing effect, and that's why spin doesn't change with like an iron or a wedge specifically. If you move the CG, if you hit it high and low in the face, spin doesn't change from the gear effect. Spin does change, can change, but the causal impact is not the gear effect manifestation on spin. It's usually like friction. So if you have somebody chipping and they're very high spin chipping, and they spin it a lot and they hit it low on the face, it's not because you get the gear effect changing the spin. It's because when you hit it low on the face, you get less debris between the face and the ball, and you get a higher friction coefficient. So the causal reason of more spin on like a wedge is very different, and why it increases when you hit low on the face is very different than a driver of why it increases when you hit low on the face. That's an important delineation there. So the curvature effectively changes the local face angle and loft, right? So you hit it low on the face, you're going to have less effective loft as that ball's smushing on the face, the gear effect happens, and then off that ball goes. So what we did on the G430 metalwoods, we used face curvature to optimize their performance, with the end goal is that we're going to get a higher effective MOI, right? And that's the ultimate goal. Like I said, optimizing the face curvature, and you can see some of the numbers over to the right. G430 driver face, when you hit it high on the face, now we're adding with 11-inch bulge radius or roll radius high in the face, you can get up to like 2.6 degrees more loft when you go a 1/4 inch up, and then you get minus 3.5 degrees loft when you go a 1/2 inch down, right? And this is going to counter the gear effect so that you can maximize distance on those shots. Okay, and again, this is literally like Elon Musk has this quote: "Engineering is magic." This technology is magic. I've absolutely loved this, and our tour players are loving the performance. I mean, especially when you hit it low on the face. Yes, all of us have probably had that experience where you hit it high on the face and you get that ball that falls out of the air, that kind of nosediver, if you're very kind of optimized on the spin threshold. So that's why we have a little more loft up there, but it's not as big of a change as the low impacts. Not only do you get the spin reduction on low impacts, but you also, because you have less loft, you're getting higher ball speed. So your net composite ball speed on the driver's higher, which again is really fun. The other thing you'll notice here is that we have a different optimization depending on our model designs. Why is this important? One, the LST, well, it's super high inertia. It's not as high inertia as the Max and the SFT because our priorities are a little different. The volume's a little smaller, it's more aerodynamic. We want to get the CG a little more forward and much lower. So that has a tighter bulge radius. One of the drivers I worked on, this is like 10 years ago, is the I-15, had a very tight bulge and roll. And I remember it like went very straight for certain players, but the everyday golfer struggled. It went like too far offline. And now it makes sense in hindsight. We had that tighter bulge was at the speeds and 3D delivery of the face was getting the gear effect optimized for the fast player, but the slow player, it was sending the ball too far offline and it never recovered because again, speed drives spin. So we have a different face optimization for every driver model in our G430 metalwoods, which is quite phenomenal. So you can just rely on that when you're fitting your golfers. This might all sound good and great, a little theoretical. What does it mean to you, and how can you showcase it to your golfer? This is what I really like, is that if you take spin differences, so if you go to this chart, the one on the left here, and this is, if you look at spin changes based on impact location on the face, so you see G425 max, when you start to hit it low on the face, over to the left over here, you can see the spin start to rise. And when you hit it high on the face, the spin goes down. G430, start hitting it low on the face, that average spin stays identical as the center impact. That doesn't mean every impact is going to be the same, because you're going to have variability in face delivery. But if you have hit enough shots, you're going to see that spin stays the same when you hit it low on the face, and very similar when you hit it high on the face. So you can actually showcase this to your golfer. I'm going to show how to do that here. Like this, you can have a golfer in. So this is an example of what we have. Have them hit their gamer driver. So this is a comparison of 425 to 430. Just have them hit their gamer driver when you're doing that fit, and look at on TrackMan or Foresight, whatever you got, that metric, which is plus or minus spin. That's your standard deviation of spin. That means, let's say if that number is like 400, that means plus or minus 400. That means if you hit 100 shots, 95 of them would be either 400, within a range of 400 more or 400 less spin. So you can do that with their gamer driver, and then you do that with the G430, and that number, I guarantee it, especially if you have the golfer hit enough shots, usually only takes like 8 to 10, sometimes even less, that number will be much, much tighter, right? And what does that mean? It means they're going to control their trajectory better in the breezy conditions. They're going to hit it further. They're going to be more optimal more often. They're going to increase their average total distance. And then that unintended consequence, they can swing the driver harder and not have to be as incentivized to hit the perfectly middle of the face. So we like to call this the consistency challenge. This is a new thing you can do in your driver fitting, is look at that standard deviation of spin. So I think hopefully gone are the days where all of you are looking at the one single best hit and recommending your driver based off of that. And so this is one layer even further than that, which is look at that plus or minus of spin and just call it spinsistency. I'm going to look at the spinsistency. I'm going to do a spinsistency comparison of your gamer versus this. You can look at ball speed, launch spin, optimization, curve optimization. You can look at dispersions on your radar device, and then boom, new thing for you to do in a driver is look at spinsistency. And you can do this not only in the driver, you can do it in our fairway woods and hybrids as well. One of the knocks on hybrids is that, hey, when I'm in the wind and I thin it, man, the ball goes everywhere. It spins and balloons. That's gone too. So we've solved that problem with spinsistency as well. And it's been a game changer on distance control in a hybrid. That's always been the knock on hybrids. Hey, I can't control the distance as good. That problem's been solved. So if you have that kind of bias in your head or memory in your head, we've innovated around that particular scenario. So that's quite fun. Let's see how we're doing on time here. I'm gonna show the story of this a little bit more, which is some this is kind of just a cool visual of how we run some simulations to see, okay, this is for a fairway wood when we were doing the G430 fairway wood. What would a dispersion look like if you put a 6-inch, a very tight bulge radius on our fairway wood? And what would it look like if you made the fairway wood face like super flat? So 17, not quite flat like an iron, but a little bit of curvature. And it's fun to kind of see the differences there of what would happen with those trajectories. Obviously, our goal is to get them curving right back to the middle. And we do not, this is an important note here, we do not use our Pingman robot when we're doing this. Why is that? The Pingman is going to deliver the face to path identical every single time. That is not what golfers do. I think you guys know that, we know that. So what we use to drive this model is hundreds of thousands of swings from our 3D motion capture system. where we know the exact face to path and dynamic loft, delivery variability, and we can break it down by different player types. That's what we use to feed our optimization. So this is a key difference where a robot actually is not optimal, because there's some places where a robot does not match what we're trying to do for the end golfer. Like, for example, we don't use our robot to test shafts anymore, like from a performance standpoint, because it just, the forces and torques that are nowhere close to what a golfer does put on the golf shaft, right? So we do all that through our 3D motion capture system. That's been a fun, nice upgrade in our R&D methodology. All right, I'm going to jump to another area which I think is quite fun, which is optimizing head weight in the driver. Okay, so this is you probably experimented with different or seen different players do better with a lighter driver or do better with a heavier driver. So we've kind of seen that, and we wanted to understand that better. And then how can we help you maybe find that perfect head weight for your particular golfer, or how can we at Ping better optimize our stock standard head weights for the marketplace? There's another problem we wanted to solve. What we're really trying to do, we're trying to pick the head weight of the driver, is we're trying to optimize the momentum. And momentum is mass times velocity. There's an equation called impulse momentum. Force times the time window that force is applied is equal to mass times the change in velocity. John, this is why the putter head travels shorter after impact, right? You lose, you get that momentum transfer, it's impulse momentum transfer there. And so what we're trying to do in the driver design is, there's a fun experiment each of you can do. I had a tour player do this with me. It was Jeff Quinney. He needed to make like a couple more cuts on tour to qualify for some pension thing. And he was like, he was a very short hitter on the PGA Tour. And he had one of our driver designs with the back weight in it back in the day. And he had just got a TrackMan, early days of TrackMan, and he was trying to find speed. He took the back weight out, and he swung it on the TrackMan, and he called me immediately, and he was like, "Marty, I picked up 3 miles an hour club head speed." I was like, "Well, that's amazing. Like, how'd you do it?" He was like, "I took the back weight out of my driver." I go, "Oh," and I go, "Oh, okay." And I go, "Well, what was the ball speed?" And he goes, "Oh, I didn't look at that yet." So I go, "Okay. Well, hit 10 more and call me back. Let me know what the ball speed was." So sure enough, what did he find? He found that he swung at 3 miles an hour faster, but his ball speed went down, right? Not only did it go down on center hits, it went down on average because he had less inertia. So what's the story there is that he increased his velocity, but the mass went down at a bigger percentage than his velocity increase. Okay, so he had less momentum. Now, that's going to be very different if you take junior golfer, female golfer, slow swing speed golfer. There is a sweet spot there where if you make it too heavy, then their delivered velocity or their club head speed is going to go down too much, and then they're going to lose ball speed. So the optimization here is there is a Goldilocks zone for everybody. Right? There's an optimal head weight for every golfer on the market. How can we solve that? Right? Club head speed, so you need to know the club head speed, and then you need to know how that particular player responds to changes in head mass. Okay, so this is where it was quite fun of using the stack to optimize our driver designs at Ping. Right? So we were trying to figure out how to solve this problem. I need to figure out how different players respond to adding a little bit more weight and taking off a little bit more weight. So we could do a test at Ping on a small scale and get data from 10, 20 golfers, maybe more. It'd be quite a bit of effort. But then we were thinking about, hey, we got data from the stack of thousands of golfers with hundreds of thousands of swings. And we can data mine that. We know whether they're male, female, age demographics, all this different data about the golfers. let's go in there and see if we can find the answer to this that would take literally decades of research to do in the lab setting, which is quite fun. It's probably the first time a training aid has ever been used to drive product optimization here. Okay, so right as of now, we have over 15,000 folks doing the stack training, and we currently have nearly 5 million swings, 4,722,000 swings entered into our app. That means we know the exact weight that's put on there. We know which radar they're using. We know the club head speed. We know demographics about the player, age, handicap, male, female, etc. So we could mine that data. So the stack, for those who haven't heard of it yet, I think probably a lot of you have, is kind of a variable inertia speed training, app-based system. Use it with the radar, hardware design, kind of like the Peloton for club head speed training. We've had phenomenal speed increases over any demographic of player here. And a fun side nugget here, John, those who haven't seen it, Sasha put this together. This is a little history of 2022 Matt Fitzpatrick training stimulus. So all the little gray boxes there are data from the app of how much he was doing his stack speed training and programs he was on, with some different timing of pretty fun events. So he started the year at Pebble at 113. He was slower than that in 2021. But started the year at 113, trained a ton, got up to 118 by the PGA Championship, which he almost won. He was in the final group, I think. 119 at the RBC, then boom, won the US Open right here. And then kept training, and he was 121 miles an hour club speed, 181 average ball speed at the Tour Championship, right? So you can see it's kind of fun to correlate training to some key events in his performance there. One of our other amazing folks who's gained the most, this is kind of the unicorn scenario here, but certainly not outside the question, is a gentleman named Josh Axler, 35-year-old. This is how much speed he's gained over, let's see, 4 different training, 6 to 8 week training programs throughout, just from December 21 to October 22. Literally, we got the data to prove it. He's gained 21 miles an hour in less than a year going through there. He's been doing some other fitness stuff and things of that nature too. It's quite phenomenal. And then the other thing we have as a quick sidebar on the stack. John, you might like this if you haven't seen it, is stack putting, which is it is a mode. It's kind of in beta mode within the stack app. And it's the most effective way to spend maybe 15 to 20 minutes on the putting green. The app, it's gamified putting. So you go to a practice green, the app tells you which putts to hit, and it tells you which putts to hit on a weighted distribution of the most important putts from a strokes gained putting standpoint, right? So you end up, we see a lot of people practicing their putting where they're lagging 50 footers, then they're block practice banging in 2.5, 3 footers. They never hit an 8 footer, 10 footer, 12 footer in their practice with subtle break, right? But then you go out to the course and that's like all you have, and that matters a lot when you're putting, right? And so the app will guide you through, stack putting app will tell you hit an 8 footer, uphill, left to right, then you report back to the app what happened with your putt. If you made it, it cheers for you, hit fast right, you can tag if you misread it or not, and you get really cool analytics on your session. And then over time, we'll determine if the golfer has a weakness in one of those areas, and you'll end up hitting more putts. Like if you're weaker in right to lefters than left to righters, you'll end up hitting more right to lefters than left to righters in your training, right? Or it might give you drills and other things to do there. So this is quite fun. I think Ben Crane has been absolutely grinding on stack putting, absolutely loves it. It's very motivating to be out on the putting green by yourself and have pressure. We report your strokes gained putting while you're putting. So you actually have like skin in the game. You have like some pressure on you while you're practicing your putting. So this is kind of fun little beta mode of the stack that's built in there. So if you get the hardware, stack putting comes for free. And then eventually we'll make kind of stack putting as a standalone offering as well. So here's an example of a small scale test that we did with our 3D system to determine that sensitivity of how much speed a golfer will gain or lose when you increase the head mass. So what we really care about here is this coefficient, 0.09. So that's 0.09 miles an hour of club head speed for every 1 gram change in head mass. And you can see that coefficient is different for different golfers. So this golfer here, Missy, her coefficient was low. That means we can add on more weight to her club head and her swing speed doesn't change that much. But this golfer here, Mike, you could start adding or taking weight from his club head mass, and his speed will start changing a ton. And that's really what we're after. And that's really the secret sauce of determining what is the optimal head weight for your particular golfer if the goal is to maximize ball speed. Okay, so here's an example, center hit ball speed, and we're using a coefficient of 0.9. That means for every 0.9 grams you add to the head, club head speed will go up or down by, or for every 10 grams you add to the club head, you'll change club head speed by 0.9 miles an hour, right? Okay, so if you had, let's say you have a driver head weight that's 210, you increase it by 10 grams, club head speed was 110, and now it'd go down to 109. Okay, that's a, it's about a 1-to-1 ratio there, 10 grams to change in club head speed. And what you see here is for the 115 player, the optimal club head mass is about 215 to 220 if your goal is trying to increase center hit ball speed. Now, that doesn't mean you'd want to do that for your particular player, probably because the swing weight would be like E5 or E1, and they'd hit foul balls over to the right all day. But it is cool to look at, then you go to a medium swing speed player at 95 miles an hour, that optimal head weight is now barely over 200. It's about 202, okay? And then you go to a 75 miles an hour player, and that optimal head weight is less than 190 grams. So how is this relevant? We've used this data to optimize our head weight designs. And for the fast club head speed player, like the LST, we have a heavier head weight, and also moment of inertia matters more. And then slower swing speed optimized product, we have a lighter head weight. So how does this optimization change as golfers have different sensitivities to adding or taking away mass, and how much their club head speed increases as they do that? It changes a ton. So depending on that coefficient, how they respond to it, like that optimal head weight changes drastically. So even in this fast club head speed range, if you change that coefficient from 0.9 miles per hour per 10 grams to 1, that optimal head weight goes from 220 over here to like 205. Okay, that's a 15 gram difference in optimal head weight. And same thing over here on the slow end. If you change that coefficient from 0.9 to 1, the optimal head weight changes dramatically, like 10 grams. So this is fun. The way we've used this is that we mined the stack data, and now we can have we can have an understanding of those different coefficients for example, male golfers, female golfers. We can have an understanding of those coefficients and how that changes for different club head speed groups. And so this is that coefficient on the bottom there. And we've gone in and we've taken the peak of these curves and used that to help inform our optimal head weight design on the G430 driver, which is quite fun. And this is from millions of swings across thousands of golfers to drive this data. So what does it mean to you? Our G430 product has different head weights, drastically different head weights depending on the particular model, right? LST 207.5 is our standard build, max at 206. SFT, we've lightened the swing weight and the head weight informed by this data, this training aid data. And then we have a brand new build, which is called the HL build that uses a lightweight grip, a little bit longer length, lightweight Ultra Quick shaft, Ultra Quick 35 or 45, in the head mass, a much lighter CG shifter in the back, and the head mass is down there between 190 and 193, depending on the model. And again, that is optimal for a slower swing speed golfer to get that right combination of mass and velocity.
Hey, Marty, I had a question here from
Yeah.
Tom about the stack system, and then I had a follow-up as well. So his question was that he's heard of a couple people getting hurt using the stack program. Is there a functionality test that you need to pass before beginning the program?
Yeah, that's a good question. Well, if anyone has been, we'd love to get any feedback. You can send us an email to info@thestacksystem.com. We'll take a look at exactly what I'm be curious what the actual injury was, some of the specifics of it. I think we've had more folks get injured, and it's much more dangerous actually playing golf than doing speed training. Sasha kind of describes this as, would any of us or any of you go out and not go out and like play badminton or tennis, right? Because you're trying to like swing that lighter racket as fast as possible. That is a much bigger change than swinging the stack with no weights on it. Or would you not go to the batting cages and with a baseball bat and go hit some balls, right? That you would be putting much more force and torque, much more vibration through your hands, going to the batting cages by an order of magnitude more than if you some of the heavier conditions on the stack. So we haven't seen that a ton, but I think certainly we have a lot of disclaimers, and certainly best practice would be certainly go through a screening, something like a TPI program or protocol, and make sure your golfer's in good enough shape. We have some single arm things in the app, like train with your trail arm, do an evaluation with your trail arm only or lead arm only. If those are in any way concerning for your golfer in terms of shoulders or things of that nature, that can be definitely skipped in the program. But certainly it's much more, you've been much more dangerous playing golf in the forces through the handle with divots and ground impact than actually doing dry swing training with variable inertia speed training.
Yeah, I have the stack system and have been using it. And two things about it. One is that Sasha does a really good job of warm-up exercises and taking you through them.
Yes.
And for anybody who's using the system, I would encourage you to, again, look at those videos that Sasha does, and just as importantly, do the warm-up exercises as Sasha explains. Because I think too many times people jump into doing something without getting the proper blood flow. It's the same thing I have with my lessons, right? When somebody comes in, I'm always putting a wedge in their hand to hit little 40, 50, 60-yard pitches just to get loosened up, to get a blood flow, much like you ride a bicycle before you exercise.
Yep.
And I think a lot of times when people are getting injured, they're just not warming up properly, right? And
yeah,
and they just jump in to try to make these full swings. So I think, the thing that I liked about the Stack app is that it tells me exactly what I should do. I just have to be smart enough to do it.
Yeah, yeah.
Right. And another thing that I'll get back to you, Marty, on this, but Mark Brody and I are going to get together here in a few weeks once it warms up here in the Northeast, and we're going to do some putting, and we're going to exchange information on green reading and putting. So what I'll do is I'm going to take the Stack system out and work with it with Mark, since he's Mr. Strokes Gained, right?
Yes.
And it'll be interesting to get the feedback from him on what he's seeing as a player. And so we'll put the Stack system through some drills. I like the Stack system a lot because the training app is second to none. You guys have done a great job with the training app in telling me, just what I need to do. And what I find myself doing is I find myself having to discipline myself because I want to go at a faster pace than the app wants me to go.
Yeah.
But that's my personality, right? Shoot, ready, aim. Right. So so I find it in doing the app, it creates a discipline to wait for the app, because the app has a timer in between each session in function and swings. So I have to wait X amount of seconds before I can take my next swing. So I think that is well intentioned as well. And I would encourage people to follow what the app tells them to do, not what they want to do.
Yeah, John, you raised some great points there. The warm up, you want to raise your core body temperature. Let's say you don't want to do this Sasha's warm up routine in the app. Certainly do something to raise your core body temperature. Maybe do it after a light feel good workout. It's a good time to do your stack training. That's what I do. So on that front, and then yeah, the app is that's, I think, the beauty of the app is that it tells you exactly what to do. It boxes you in, and resting the right amount is very important. It's very calculated, like that rest time. This is like lifting weights. You want to have a certain recovery time before you go in and put that max effort in. So there's the rest that you want to follow in the training session. And certainly a lot of times we'll have you rest for like 3 minutes between your set of 6 or 8 swings and your next set. And it might feel like a long time. Oh, I got something to do, somewhere to go. But try to just carve that time out. The app tells you when you're going to be done. If you need to tell somebody or something. And then resting the right amount between those training sessions is also very important. We actually see some folks, the app will give you a window. It'll be like train within 48 hours and 72 hours of your last session. Some people are so into the stack and to training and after gaining club head speed, they always train right there at 48 hours later. And that's sometimes when they get stuck, is that even resting 2 days every single time is not enough. So once in a while, just take 3 or 4 days, then do your next session. A lot of times that's when people break through a plateau or set personal records in the app. So that's
right.
A little tip and trick there is that window doesn't need to be followed perfectly. So your rest time and your recovery time is very important. And the app actually has a score in there. It's called your grit score. That has nothing to do with whether you're gaining speed or not. It has everything to do with, are you resting the right amount and following the protocols in session and between days. So if you maximize your grit score, then we have a great teaching solution. So you can kind of outsource your speed training to your students. You can monetize it, charge folks for it. We have a coaches solution where you can add players into your stable. So there's some great videos on our website. We'll send some stuff out after the event, there as well, to how you can use it as a coach. But get a couple stacks in your teaching center, coaching center, and you can have a stable of a bunch of students in there that come in and use it, have speed competitions, etc.
And then one more question from Joe D, who's actually at Pelham, where Mark Brody is a member. With the stack, have you seen players swinging the lighter weight as fast as the heavyweight?
As fast as the heavyweight, much faster. The lighter weight's much faster than the heavyweight.
That's been my experience.
Yeah,
personally.
and yes, and the everything I showed here in this data shows how there's variability. Let's see if we can go back in here. Everything in this data right here shows how there's variability in how much that sensitivity of mass to club head speed changes for individual golfers. There can be different players are going to have a different sensitivity to how they respond to that speed. And that's part of head weight optimization. And
right.
that drives the intelligence of the app, by the way. So the app takes you through an initial session, evaluates this, and it creates a custom program based on where you're at in your force velocity profile and how sensitive you are to increases in mass. And the app is always looking at your training every session and reconfiguring and optimizing your training loads.
And then, Marty, you used a term that I will steal, but I will definitely give you credit each time I use it. The momentum transfer.
Yes.
In the putting. So you had mentioned with the momentum transfer with longer backstroke, shorter through stroke, that occurs. I'm just wondering here, if I had which I see a lot of, and I do not like, I see through strokes longer than backstrokes
Yeah.
on putting, right? Can I assume that I'm not getting the same momentum transfer when I see that?
I think what you would be seeing is just a gross overload of like very high acceleration through the putt, right? I think the more acceleration there is through the putt, the more force is being applied from the golfer through the handle to move the putter forward. And you would be determining less of what's happening with the momentum transfer because the golfer has still like the primary control over the putter if they're over accelerating it. So I think you'd be able to just learn less in general in that case.
Right. So I'm not getting that same momentum transfer, that same solid feeling of hit.
Yeah, there's still the momentum transfer, but I think what you'd be seeing is that high rate of change of club head speed depending on ball position, basically, effectively for the player.
And the thing that I see a lot of is very poor distance control with those players.
That makes sense to me from a theoretical standpoint, yes.
Because when I see that with anybody, when I'm doing my green reading clinics or giving putting, as soon as I see that, I just know that this is going to be an easy lesson.
Yeah.
I'm not going to have to break a sweat.
Yeah.
All right, great. We're all caught up. Thank you.
Yeah, great questions. So I talked a little bit about this HL build, so G430 high launch. This is really a great build across our whole family, which just provides a lighter total weight solution across our whole family. So we have these lighter silver colored back weights and CG shifters. So this is a system design. That's the important thing to understand here. It's not just like lightening the head. This is a lighter grip. We partnered with Fujikura on 2 shaft designs, the Alta Quick 35 and 45. Kind of similar. You can think of this as kind of a replacement for the Distanza shafts. These are kind of soft, regular, and softer than the 45, 35 from a flex and stiffness standpoint. Lighter CG shifter, get the whole system mass about 15% lighter than our soft regular build in the Alta CB. CB stands for counterbalance. This has been a great option, but you don't want to overuse it for somebody that's swinging the driver with ample speed. This is really a targeted, you want to get surgical with how you use this high launch build to the slower swing speed player. Golfers swinging their driver 85 miles an hour and less. If anything, we've seen that even on the slower end than that, 80, 75 miles an hour and slower. Try this Alta, try this HL build with those particular players, and you might see really good results. And again, what we're doing is we're doing a better momentum optimization. We're helping the golfer square the club easier. I've talked a lot about head weight here, but also there's you want to marry that with the right kind of swing weight of the build to optimize the face to path delivery, right? And that's kind of comes to swing weight fitting. So I don't want to get us too focused on like optimal head weight only without considering other factors in the fitting process. But I do want to present that research on it. So this is a fun product offering from us in the G430 family, total system mass design. Yeah, fairway woods. I think what's cool about the fairway woods this year is we've done that consistency optimization. You can still showcase that to your golfer. But the fairway wood and hybrid, they use this carbon fly wrap like the LST driver. It's more impactful on the fairway wood and hybrid than it is on the driver. Why is that? Because we're trading steel instead of titanium. So we save 10 grams. The theme of our G430 fairway hybrid and irons is lower CG. It's as if we're putting the ball on the tee for the player, even though we're not, right? We're helping them hit net effectively higher on the face. So it feels better. We're getting higher ball speed. We're controlled spin ratios better and hitting the ball further. And then we optimize the bulge and roll to make them more forgiving. So yeah, SFT max, fairway wood, and then 2, 3, 4, 5, 6, 7 hybrids that again have that optimized face curvature. And the question is, now we have all these options in high lofted fairway woods and hybrids. How do you build the whole bag? Use our Copilot tool to help figure out blend all these together so that your golfer, you can fit them and they're going to have really good distance gapping and set configuration well beyond the day that they were fit. We have some great shaft offerings in the line. The last thing I want to cover here, we got about 10 minutes left or so, is this concept of like 7-iron fitting. Like, what's a good spin rate in your 7-iron? Landing angle, how do you address that? And then set configuration, right? So what's the longest iron I should play? How should I build my bag? What's a good spin rate in my 7-iron? How do you do that full bag fit? Talked about our spin rate guide. That's kind of a, you know, then we want to answer that question of what's optimal in irons. And this is where we data mine to look at changes in vertical launch based on swing speed type. You can see higher swing speed players launch the ball lower, but does the ball fly higher or low? But does the ball fly lower? No, it flies higher. So they launch it lower, they spin it more, and their landing angle steeper. So their ball speed has a lot to do with that peak height. Both spin, but it's not all spin. It's primarily ball speed. Ball speed in irons drives peak height. There's another advantage. Use the stack system. You swing it faster. It's going to help you land it steeper and stop it faster with your irons. Not just about your driver. So in iron fitting and set configuration with the G430, we have an extra wedge included. We have that really good understanding of the gapping. That's where that gapping app comes into play that we showed. But for now, you can use the Copilot set configuration app, help optimize that player's full bag scenario. So why is gapping important? So G430 iron, I'm super excited about it because we have technology in the face design and the badge, where the badge is very flexible. So we kind of figured this out. We had to do a test on the G425. We took the badge out and we got a lot more ball speed and peak height. But if we take it out, like it impacted the acoustics a lot, right? And so what we did is that G430 badge is super flexible. Should have had one in here with me to show you guys on the Zoom meeting here. But because it's super flexible, we get more ball speed from the face, which helps us drive the peak height. So I know all of you hopefully are just agitated by a lot of the irons out there that they go further. They might go further in your simulators, in your bays, but their irons don't spin enough, right? I think we have an epidemic going on out there with distance-minded irons that aren't spinning enough and going too low. So I'm most excited about G430 because yes, it goes 7.5 yards further. That's great for the customer. It's great for you to help sell it to them. But what you should be excited about as the fitter and the coach, helping the golfers play better, is that they go higher and they land steeper. Number one. Number two, it's a distance set with really good gapping. That's going to be hard for you to tell that story or showcase that in your fitting. But I'm going to go under the hood here and show you how we arrived at our loft configuration, why we did that. Okay. So we're getting 3 more yards from 1 degree more stronger loft in the iron. We're getting 1.5 more from face flexing. We're getting 3 from the lower CG. So you add all that up, 7.5 yards for the average player. For me personally, I hit it like, 15 yards further for a fast swing speed player. Your average player is going to gain that much. This is super exciting, is that we're putting an ample amount of spin and we're generating way more peak height than our competitors, right, in that space. That's very important to us. I want to highlight that to all of you. Something you should be looking at and focusing on in your iron fittings, like how much is the golfer spinning it? If they're not spinning it enough, that's where you can use golf ball to help also get them to land it steeper. That's where ball dynamic comes in and fitting ball and club together synergistically. So this is really fun. We've had a partnership with Arcos, and it's been great to have access to all this data. And we have data scientists here. Mark Brody's son, Chris, is our head of fitting science, one of our core data scientists here to help us go into the data and extract meaningful insights that we can then feed into our designer fitting process. So we could go in, we went in and looked at our distance gapping from our ping golfers with our clubs. We know exactly what clubs they are on the golf course. What is their iron gapping look like? So we could do a gapping test on our range. Then we look at Arcos data, do those two things marry up. And we're always kind of asking those questions. And what we found is that a zero line here would be perfectly spaced gaps between all your clubs, okay? And what we found is that 9 to pitch, 8 to 9, 7 to 8 range, we saw bigger gaps there. And obviously I think the whole market's kind of, okay, strengthen your irons. Something's got to give, like somehow you got to get from your irons into your wedges with the right spacing. And so we had this growing distance gap in your wedges. I noticed this when I play in pro-ams. I would play in pro-ams here in Arizona where somebody got some distance iron set, amateur golfer, and we spent all day from 140, 135 yards in a pro-am, and they got a sand wedge that they hit 100, and they got a pitching wedge they hit 160. You know, so they got nothing where they're spending all their time on the golf course. So we data mined our Arcos on-course play data. And so what this chart is really cool. This shows what club the player's hitting from different distances from the hole. So red being driver, dark green being like sand wedge, lob wedge. And I think yellow, like this medium colored yellow greenish color is like a 7-iron. And here's what you see is that a majority of approach shots, this doesn't matter whether par 5, par 3, par 4, the peak of your approach shots is from like 145 to 150 yards. That is the case regardless of how far you hit the golf ball off the tee. That's the conversation for golf course architects we need to have and tee it forward campaigns we need to have, is that players, whether you hit it far off the tee or short, the distribution of where you're hitting those approach shots is about exactly the same. Now, obviously, me as a further hitter, a lot of you, we're going to be hitting a shorter club in from there. 9-irons pitching wedges, where your slower swing speed players can be hitting 7-irons, 8-irons. But this is a really cool visualization. Now, how does this relate to our G430 product? Well, our gapping that we were designing was leaving the biggest gaps, right? The most problematic spacing in your distance in the area where golfers are spending the most time playing golf, okay? So this is the opportunity. This is why in the new G430 iron, we introduced a new club into the bag, right? We made the 7-iron go further, then we added another wedge in the bag so that now we have that very even spacing. Going the wrong direction here. Now we have that very even spacing in the exact location where golfers need it the most. I think this is a really cool story of how we use big data, on-course data, real-life play data. And we're not just collecting the data, we acted upon it. We're using it. Now you can tell that story to your golfer. Hey, Pink's got a new, I got to get your set design. It's going to be a little different. You're going to go from wedge. You're not going to U-wedge anymore. You're going to go wedge 45, 50. We got another wedge in the bag. Here's the story of how Ping found it, and you're going to end up with better distance gaps on the course, right? I think that's quite fun and quite exciting. And then our gap testing kind of match that. So
Marty, what's your wedge at now?
Here's our loft designs. So we go wedge at 41.
Okay.
And then we go 45 degree at 45 and a half. And then we go 50, 54, 58, right? Mm-hmm. So yes, I think the reaction might be, oh man, Ping's making a 41 degree wedge. This might be new. This might be new and different, but I think the benefit to the golfer that they're going to have tighter spacing right here where they need it the most is quite phenomenal. I think it's a fun story to tell. But those are exact lofts, and hopefully you guys know enough that even loft gaps do not deliver even distance gaps by this time as well.
That's interesting. And then so you're a wedge at 41.
Yeah, W at 41.
And then where's your 9 going to be?
It's right there at 37.
37. Okay,
yep.
4 degrees.
Yep.
Yeah, I think that wedge gapping is so important because the majority of people that I see are those low to mid handicappers, and even the guys towards scratch. They do not have good gapping. They do not have the right wedges, and they obviously cannot. They're always having control distance problems.
Yep.
And so I think that's really cool that you're doing that. It's to me, that's like the old 2-wood for the guy that can't hit the driver, right?
Exactly.
That was a great that, and that's such a scoring area too.
Yeah. So this is a very important thing, providing more clubs where golfers exactly need it the most on the golf course, right? And we wouldn't have been able to solve this problem without that Arcos data. This is like, Mark Brody being a consultant for a tour player looking at their shot link data. Like, we're doing the exact same thing, but for the everyday player, which I really love, democratizing the use of big data for our end golfer. It's not just reserved for the tour player elites. This is the use of real on-course data play, plugged right into product optimization. That quite frankly, you're not going to see. You're not going to notice the benefits of this in your fitting, right? This is a post-fitting, play your best golf solution. Important story for, I think, all of you to tell with your customers. So hopefully this helps get over the hump. Oh, Ping's doing crazy stuff with their iron loss, and they got a new wedge, and whatever friction and frustration and new and different that comes with that. We just feel very good. Fundamentally, it was the right decision to make for our end golfer playing better golf on the course.
That's definitely an asset, and something that all of our club professionals and fitters need to be aware of, because that's the lowest hanging fruit when we're looking at, if we wanted to lower handicaps, which we all do.
Yeah, absolutely.
Scoring clubs.
So John, I think at this point we can take any last questions, and we're kind of hitting our limit here, hitting our time limit. And I'm super appreciative for everyone's time and attention, given the opportunity to show hopefully some fun product data performance stories here.
Marty, you always make 2 hours go so quickly. Everybody enjoys having you on. You do such a good job for us, and we're very appreciative of you and Ping, who is also one of our sponsors here in the Met section, to give up your time. I know that you're in a little different time constraint than we are, but you have children, so you're up early anyhow. Yep. Tell me, Marty, with your tour players, right? Are you seeing any difference in the shafts that they're using in their irons? Do we see any of your tour staff going to graphite?
Good question. We actually don't have a ton. I think we have so many. I think our staff is kind of trending with the macro trend of the tour, which is both younger and swinging faster. And so with those trends, there's not really a major trend to go like lighter, right? So I think in iron shafts, like, weight is the biggest driver of performance, right? Over flex. Like, it's more important to optimize the weight and then the feel. And so we haven't necessarily seen that trend happening with our staff, and I think it's related to the speed and age and strength and speed of our players.
And as far as breakthrough players coming onto the scene, Thagala is always knocking at the door here. Is he as talented as we think he is?
Yeah, we're bullish on him, man. I was out watching him at the Phoenix Open. He's super impressive, and he's just got a lot of moxie. And once I think he's one of those guys, man. Once he breaks through, it's going to be look out.
Yeah, I think he's very much like he reminds me of Homa, that once he does break through, that he's going to break through on a more regular basis.
Yep.
Because he's had a number of close calls, some of them actually in Phoenix, right?
Yes.
At the Waste Management, and he just seems like he is. He just needs a few breaks here, or a better last round. But certainly impressive young man.
Yeah, I love. He's my favorite up and comer on our staff to watch and follow, and hopefully kind of breaks through and get that momentum going.
Yeah, it'd be great for golf, great for Ping.
Yeah.
Marty, I appreciate everything you did for us. Thank you very much on behalf of myself, the section here, and you're going to send some data out to us. You said some follow-up email.
Yeah, we'll absolutely kind of get instructions for how to get into Copilot, get access to it. iPing, if you need a cradle, directions to the app. We also have a very fun, exciting new advanced education platform called Ping Proving Ground Certified. which is similar to kind of like a TrackMan University content, but less on radar and golf and impact and deep plane stuff, more on all the science of friction, kinetics, kinematics, spin generation, shaft fitting, how they bend. So it's the theoretical side, and then the practical, how to use it in your fitting environment, launching some, later this spring as well. And we'll send information on how to get registered for that Ping Proving Ground certified course as well, which we're super excited about. I think the folks in the med section are going to be super into that course content.
And how about you and your playing? Are you going to be playing in the national championship again?
Yeah, so excited about that. And you know, that's what I love about golf. Every year you start at zero, you got to earn your way into into the bigger event. So that's going to be the goal for the year.
Great.
And been doing the stack, trying to work on my training, my fitness, and hopefully have a good year playing.
All right. Good luck with that. We appreciate that, and you're playing and enjoying your skiing up there in Flagstaff with the kids.
Yeah, that's quite fun too. Ditto. Have fun today if you're out there.
I'm sure we will. I'm going to be going to the slopes here in a few minutes. Thank you so much, Marty, and thank you everybody for being on. And we look forward to seeing you on our next seminar coming up next week.